Take a look at this hole in the mountains southwest of Salt Lake City, Utah. It's 2¾ miles across at the top and 3/4 of a mile deep, big enough that astronauts have identified it by eye from orbit, one of the very few man-made structures on Earth that can make that claim. It's called Bingham Canyon Mine, and it has produced more copper than any single mine in recorded history, over 18 million tons of it. It has been running continuously for more than 100 years, survived a landslide so massive it briefly made international news, and today, in 2026, it is still actively expanding, with plans already in place to keep pulling copper out of the ground through the 2030s. So how did one canyon in Utah become the single largest hole humans have ever dug? And why, after everything that's happened here, is it still making money? What's actually down there? Bingham Canyon Mine currently spans roughly 27,000 acres of company-owned land in the Aquire Mountains, though the visible open pit itself is a smaller, staggering core of about 1,900 acres. To put the scale in perspective, the pit is deep enough that you could stack two of Chicago's Willis Tower, one of the tallest buildings in North America, directly on top of each other inside it and still not reach the rim. The pit runs 24 hours a day, 365 days a year, and produces copper alongside meaningful amounts of gold, silver, and molybdenum. More recently, it has also become one of only 2 American sources of tellurium, a rare metal that happens to be a key ingredient in certain types of solar panels, quietly making a 100-year-old copper mine relevant to the modern clean energy supply chain. Rio Tinto, the mining company that now owns the site, employs more than 2,000 workers here and has already committed hundreds of millions of dollars toward expansion projects designed to keep the pit productive well into the next decade. Why the ore here is so unusually abundant? The reason Bingham Canyon holds so much copper comes down to a specific and relatively common type of deposit called a porphyry copper deposit, though this happens to be one of the largest and richest examples ever found. Roughly 40 million years ago, as ancient tectonic plates shifted along the western edge of North America, magma rich in copper and other metals slowly pushed upward from deep within the crust and cooled beneath the surface here, in what are now the Aquire Mountains. Instead of concentrating into a single rich vein, the way many metal deposits do, the copper in a porphyry deposit spreads out through an enormous volume of surrounding rock in tiny, widely disseminated specks, meaning the ore itself is actually quite low grade, often less than 1% copper by weight. What makes porphyry deposits valuable isn't concentration, it's sheer scale, and Bingham Canyon happens to sit on one of the single largest volumes of this kind of ore ever discovered anywhere on the planet. Deposits like this form in clusters along ancient volcanic belts, and geologists have found similar porphyry systems scattered from Utah down through Arizona and into parts of South America. But few anywhere in the world combine the size, grade, and sheer longevity of the ore body sitting beneath these particular mountains. Cattle, a curious kernel, and a report that changed mining forever. Copper wasn't even the original draw here. In 1848, 2 Mormon settlers named Sanford and Thomas Bingham first noticed mineral deposits while grazing cattle in the canyon that would eventually bear their name, though small-scale mining that followed in the 1860s focused mainly on gold and silver. It wasn't until 1887 that a mining colonel named Enos Wall had the surrounding rock assayed and realized the canyon held enormous quantities of copper, though at grades most mining experts at the time considered far too low to ever be profitable. The real turning point came in 1899 when engineers Daniel Jackling and Robert Gemmell produced a report arguing something that sounded almost absurd for its era, that this low-grade ore could still be mined profitably if it was extracted in truly massive volumes using steam shovels and railroad cars instead of traditional underground tunneling. Nobody had approached a copper deposit quite like this before. Jackling's idea essentially invented the modern open-pit copper mining industry, an approach that would go on to be copied at massive mines around the world over the following century, and in 1903 the Utah Copper Company was formed specifically to put his theory into practice, backed by investors willing to bet that scale alone could turn barely profitable rock into one of the most valuable industrial sites in the country. From cautious start to wartime boom. Open pit mining finally began in earnest at Bingham Canyon in 1909, after several years of preparation and skepticism from investors who still weren't fully convinced Jackling's low-grade, high-volume approach would actually pay off. It did, and then World War I arrived and changed everything. Wartime demand for copper, used extensively in ammunition, electrical wiring, and military equipment, sent production soaring. Between 1910 and 1917 alone, the amount of ore processed at Bingham Canyon more than doubled, jumping from roughly 64 million tons a year to more than 143 million tons, with the value of that output climbing from about $16 million to over $67 million in just 7 years. What had once been considered marginal, barely profitable ore became one of the most important industrial sites in the entire country almost overnight. The mountain that moved the mine's modern history includes one genuinely dramatic near disaster. On April 10, 2013, an enormous section of the pit's northeastern wall gave way in one of the largest landslides in North American history, sending well over 100 million tons of rock crashing down into the pit in a matter of minutes. It could easily have been a catastrophic loss of life. Instead, monitoring equipment tracking tiny movements in the rock face had picked up warning signs in the days beforehand, giving engineers enough time to evacuate the area completely before the slide occurred. Not a single person was injured. The event briefly shut down operations and even registered on seismic monitoring equipment as a small earthquake, but within roughly a year, Rio Tinto had cleared enough material and stabilized the pit to resume normal production, treating what could have been the end of the mine as simply another obstacle in a 100-year history full of them. Why it is still worth digging in 2026. Rio Tinto has spent the last several years pushing the mine's lifespan even further, expanding the pit's south wall and deepening operations in a series of projects designed to keep Bingham Canyon productive into the early 2030s. Alongside newer underground mining development beneath the existing pit to reach ore, the open pit method can no longer economically access. Copper demand globally continues climbing as electric vehicles, renewable energy infrastructure, and expanding power grids all require far more of the metal than previous generations of technology ever did. And a mine that already has a century of infrastructure, permits, and expertise built around it has an enormous head start over any brand new copper project trying to start from scratch anywhere else in the world. So the hole outside Salt Lake City just keeps getting bigger, more than a century after a cattle rancher first noticed something unusual in the rock, and nearly 2 decades after a mountain briefly gave way and threatened to end the whole operation. It was built on an idea that most experts in 1899 assumed was too optimistic to work, that a mountain of barely profitable ore, mined at a massive enough scale, could still be worth more than anyone imagined. That bet paid off for over 100 years, through 2 world wars, a Great Depression, a landslide that could have ended everything in an afternoon, and a complete shift in what the world even needs copper for. Rio Tinto is still making that same bet today, and so far, the mountain keeps proving them right. If you want to see more of this, please like and subscribe.